In this video, we will be looking at why there is inconsistency in the notation of discrete state-space model. This video does not require any prerequisite, so it's fine if you have heard the term state-space model for the first time. If you prefer text format over video format, then you could also refer to my blog on the same topic. Link is given in the description. State of a building could be defined by its displacement and velocity measured at its few locations. Input force due to wind could be measured using pressure sensor. Based on this sensor data, we know the state of a building X and input force U at time step K. Suppose we want to find the building state at next time step K plus 1. For this purpose, we need to know the relation of Xk and Uk with Xk plus 1. This relation is given by a mathematical model called as discrete state-space model. Sensors are only capable of measuring data at only discrete time. Hence, we have issue of missing data, and corresponding to this missing data, we need to assume some approximate value. Accuracy-wise, best solution would be to consider linearly varying input force U. For this case, we get this discrete space model, which is a function of xk, u1k, u2k up to unk. As this discrete space model is a function of many variables, so it is not computationally efficient. To reduce this number of variables, we have alternate solution. Assuming constant u, we get simple discrete state space model which is function of just two variables xk and uk. At the end of this video, we will derive this discrete state space model where it would be more clear to us. One could also assume constant u in other manner as shown in white color line. Then we would get discrete space model which is a function of xk and uk plus 1. Both of these discrete space model are correct, so it is okay to use any one of the notation for discrete space model when the input is external disturbance. In case of external control input, this input is given by controller, so it is known to us. So there is no need to assume any missing value as was required in case of external disturbance input. In control, state of dynamic system is measured and then based on this state, control input is given to the system. So this is sequential task. Hence, discrete state space model is given as xk plus 1 which is a function of xk and uk plus 1. Now, let's look at the derivation of discrete state space model to understand why assuming u to be constant is helpful. Let x be scalar to make our derivation easy. The LHS term can be easily integrated if u is assumed to be constant in the time interval tk to tk plus 1, where tk plus 1 is excluded. Integrating both sides, then taking exponential of both sides, and after rearranging few terms, we can arrive at the discrete space model, which is just a function of xk and uk. The format of this video lecture was inspired from Brian Douglas' YouTube channel.